Welcome to the first video of Powers and Exponents series. With this topic I am planning to make 3 or 4 videos. In the first 2 videos I am planning to go over the properties and the rules, and then in the last 1 or 2 videos I am planning to solve some challenging questions. Before starting, let me tell you what the topic is about. Let's say we have 2 times 2 times 2 times 2. There are how many 2's? 1, 2, 3, 4. So this is gonna be equal to 2 to the power of 4. Actually, what we do here is, because the numbers that are at the top of the number, we add them up, and 2 to the power of 1 plus 1 plus 1 plus 1, which is equal to 2 to the power of 4. Here, we call this number as exponent, and then this number is called base, and then the whole term is called power. So we can write something like this in the general form: a times a times a times a. Suppose that there are 10 times a. This is equal to a to the power of n. So as an illustration, we can say that, for example, 10 times 10 times 10, this is equal to 10 to the power of 3. Why? Because there are 3 tens. Let's take a look at the properties. Number 1, a to the power of m times a to the power of n. If the bases are the same in this multiplication, we add the exponents. So this is going to be a to the power of m plus n. Let's take a look at an example. 2 to the power of 3 times 2 to the power of 4. As you can see in this multiplication, bases are same, so we just add the powers up. So this is going to be equal to 2 to the power of 3 plus 4, which is 2 to the power of 7. And property 2, a to the power of n times b to the power of n times c to the power of n. If the exponents are same and the bases are different, what we can do is we can write the whole expression inside a parentheses, like a times b times c to the power of n. Let's take a look at an example for the second property. Suppose that we have 2 to the power of 3 times 3 to the power of 3 times 5 to the power of 3. We can write the whole expression as, in a parentheses, 2 times 3 times 5 to the power of 3, which is equal to 2 times 3 is 6, 6 times 5 is 30. So this is 30 to the third power, which means that we can write this expression as 30 times 30 times 30. So just calculate the numbers. 3 times 3 is 9, 9 times 3 is 27. And how many zeros are there? 1, 2, 3. So add 3 zeros at the end of 27. So the final answer is 27,000. Without taking them into the parentheses, if you multiply those numbers one by one, then finally we can get also 27,000 as well. For example, 2 to the power of 3 is 2 times 2 times 2. Times 3 to the power of 3 is 3 times 3 times 3. 5 to the power of 3 is 5 times 5 times 5. If you multiply 3 2's, okay, you're going to have 8. If you multiply 3 times 3, you're going to have 27. If you multiply 3 times 5, you're going to have 125. And if you multiply 8 by 125, you're going to have, okay, let me write it here, 8 times 27 times 125. If you multiply 8 by 125, you're going to have 1000 times 27, and still you're going to get the same result, which is 27,000. And let's take a look at the third property. Let's say we have a divided by b to the power of n. Here this n comes to both numerator and denominator as an exponent, so this is equal to a to the power of n divided by b to the power of n. Let's take a look at an example. Say we have 10 divided by 2 to the power of 3. This 3 comes to both numerator and denominator as an exponent, so this is going to be 10 to the power of 3 divided by 2 to the power of 3. 10 times 10 times 10 divided by 2 times 2 times 2. And if you simplify this expression, if you divide 10 by 2, you're going to have 5. If you divide 10 by 2, you're going to have another 5, and we have another 5 from here. So there are 3 5's, and if you multiply them, 5 times 5 is 25. 25 times 5 is 125. Actually, you can get the same answer by just dividing 10 by 2 and take the third power of it. So this is going to be 10 divided by 2 is 5, 5 to the third power, and again this is 125. We can get the same answer. Fourth property, if you take the power of the power, like a to the power of m to the power of n, you need to multiply the powers. A to the power of m times n. Let's take a look at an example. 2 to the power of 3 to the power of 4. 2 to the power of 3 times 4, which is 2 to the power of 12. And now let's take a look at the fifth property. If you take the negative 1 power of any number, like a, for example, in this case, so you're gonna write numerator into the denominator, denominator into the numerator. Actually, this a is a divided by 1. So there is 1 in the denominator part. If you write upside down, then it's going to be 1 divided by a. As an example, 3 to the power of negative 1 is 1 divided by 3. So 5 to the power of negative 1 is 1 divided by 5. And sixth property, a to the power of negative n is 1 divided by a to the power of n. This property comes from the previous property actually. A to the power of negative n can be written as a to the power of negative 1 to the power of n, because if you take the power of the powers and the powers are multiplied, and then we can get the left term, so they are equal to each other. Here, a to the power of negative 1 is 1 divided by a to the power of n. If you take the n power of numerator and denominator both, 1 to the power of n divided by a to the power of n, 1 divided by a to the power of n. So as an example, 3 to the power of negative 2 is 1 divided by 3 squared, which means 1 divided by 3 times 3, which is 1 divided by 9. So let's say 5 to the negative third power is what? 1 divided by 5 times 5 times 5, which is 1 divided by 125. And now let's take a look at the seventh property. A to the power of n divided by a to the power of m. Here the bases are same, so we just subtract the exponents. So this is going to be a to the power of n minus m. Let's take a look at an example. Suppose that we have 5 to the power of 6 divided by 5 to the power of 3. What you can do is this is going to be equal to 5 to the power of 6 minus 3. This is going to be equal to 5 to the power of 3. You can prove that you can get the same result by just simplifying the terms. For example, 5 to the power of 6 is what? 5 times 5 times 5, 2, 3, 4, 5, 6. 6 5s there, and there are 3 5. 1, 2, 3. So this one goes out, this one goes with this one goes with this one, and now the leftovers are these. If you multiply them, you get 5 to the power of 3. As you can see, you can get the same result. In eighth property, actually I'm gonna just remind a few things. For example, a to the power of 1. If you take the first power of any number, it's gonna be equal to itself. So this is a, for example, 5 to the power of 1 is 5. Negative 10 to the power of 1 is negative 10. And another thing is, if you take the 0 power of any number, like for example a to the power of 0, this is gonna be equal to 1, but here a should be different from 0, so it cannot be 0. Why? Because 0 to the power of 0 is undefined. So 5 to the power of 0 is 1. Negative 10 to the power of 0 is 1. Pi to the power of 0 is 1, because pi is a constant. If you remember, it's 3.14, and it goes, so e to the power of 0 is 1. So we have learned the first 8 properties or rules in powers and exponents topic. Let's have an example. If you want, you can pause the video and then try to solve it by yourself. I will continue to solve it. 10 to the power of negative 1 is 1 divided by 10, plus 10 to the power of negative 2 is 1 divided by 10 squared, plus 10 to the power of negative 3 is 1 divided by 10 cube. So this is gonna be, okay, let me write it again one more time. 1 divided by 10 plus 1 divided by 100 plus this is 1 divided by 1000. So if you divide 1 by 10, because 10 has 1 0, then just write the numerator, which is 1. By starting from the right side, count 1 time towards to the left side. Come over here, put the point here, and then put the 0 here. Plus 1 divided by 100. Write down the numerator, which is 1. Because 100 has 2 zeros, by starting from the right side, count 2 times towards to the left side. 1, 2, put the point here, and then put 0 here, and then put 0 in the empty space. Plus, if you divide 1 by 1000, just write down the numerator, which is 1, because 1000 has 3 zeros. By starting from the right side, count 3 times. 1, 2, 3, put the point here and then put zeros here. So basically what we're gonna do is we're gonna add 0.1 by 0.01 and then 0.001. Well, how we can add these decimal numbers? If you remember, we were writing them like this: 0.01. The first thing you should consider is the points should be in the same column. Okay, you have to put points in the same column and then write down the numbers after the points. So because there is no number here, we can just put 0 at the end, put 0 here also, and now we can add those numbers up. If you add 0, 0 and 1, we're gonna have 1. 0 plus 1 plus 0 is 1. 1 plus 0 plus 0 is 1, and the point comes over here, and then 0 plus 0 plus 0, which is 0. So this is the result, 0.111. Okay guys, let's leave it here for the first 8 properties. For the rest of the properties, we can continue with the next video. Thank you for watching.